At least it's better than last year. Last year, last year my dad was like, "It's gonna be so good."
So 120 divides by 4. Well, 12 divides by 4, so 120 will also divide by 4. So 4 times 3 is 12. 4 times 30 is 120. So I'll rewrite that as a perfect square factor. 30 does not square root, but we can square root 4. So I'll cross out the 4 and I'll square root it. When I square root it, I write the square root outside the radical. So the square root of 4 is 2. And because it was negative, I'll write an I with it. Just telling people who are reading my work that I square rooted a negative number. That's it. Final answer. When you're having to multiply radicals, particularly if they're negative, you want to simplify before you multiply. So 10 only divides by 2 and 5, and neither one of those will square root. But it's negative, so I will simplify by putting an I out front and making it into a real number. The radicand is real. And 24 divides by 4, so I'll consider 24 to be the same as 4 times 6. Square root the 4 and make it 2i. So this is my new problem. I looked at this separately, took the I out. Look at this, broke it down, and now that I've simplified them, now I will multiply. When I multiply, I do these numbers in front. I times 2i will be 2i squared. And I'll do the numbers underneath. 6 times 10 is 60. Because 5 doesn't square root. So I'll keep going. I squared, every time I squared comes up in a problem, I replace it with -1 equivalent. And 60 divides by a lot. Divides by 2 and 30. Divides by 15. It divides by 30, it divides by 15, right? So it's 2 and 30. It must be 4 and 15. So again, we'll square root 4. And when there's already a number in front, and you square root, you're going to multiply out there. So what we have here is 2 times -1. So our product will be -4 square root 15. I didn't forget about it. It was I squared, and I replaced it with -1. So there's ways to show less work. Like, did you show less work and you're wondering if it was enough? You can put your phones away. Devices shouldn't be out. Get your devices all the way off your desk, or I'm gonna walk by and grab them. Yes. No. So making it yeah. I-24 I squared 240 -1 240. You go. Technically it's fine. Sometimes it's better. Keeping your numbers small is also a good strategy. All Alright, let's try some with variables. Like you had to do in your workbook. Well, I did that. So this is number 3 and 4. So on your workbook, you had some problems that had x's and y's and you had a fraction. So start with the 98. Divided by 4? 98 divided by 4 evenly? No. You guys grab a calculator. You gotta practice it yourself. Don't wait for everyone else to come up with the numbers. 98, what does 98 divide by? It doesn't divide by 4, so is there anything else? It doesn't work. Yeah. You should get yourself a fancy calculator. 2? 2 and 1? Looks like there's 2 right here. 2 and 49. So that's helpful. 49 is a great perfect square. So we'll rewrite this. 49 times 2. X squared y, and that's a z to the 5th there. The square root of 49 is 7. So with these variables, I will show you a longer way to do it. You don't have to show all this work with these variables, but this is just one way to start. So x squared is 2x's, y, and then we have z to the 5th. When you're square rooting, every group of 2 can square root. It's just like this. Like the reason the square root of 25 equals 5 is because you're square rooting 5 squared. And the truth is that a radical bar and an exponent cancel each other out. Square rooting is the opposite of squaring. So if you're square rooting something squared, they cancel, leaving just that value. So like the square root of x squares, the radical and the exponent cancel, leaving just x. They're opposites. It's like adding and subtracting at the same time. Square rooting and squaring at the same time, inverses. They cancel each other out. So every group of 2 can be simplified. So x squared I'm going to cross out and I'll bring 1x to the outside. It's a group of 2. Y can't be simplified. It doesn't have a group of 2. For z's, I got 2 here. I'll cross them out and I'll bring a z on the outside. Another 2 cross out, bring a z on the outside. So this one that doesn't have a partner stuck under the radical bar. So I have 7x z squared square root. What's left underneath is 2y z. That's it. Every group of 2 variables brings 1 to the outside. So eventually, and it won't be in this chapter, we actually do this in semester 2 again, but eventually when you see like something to the 5th, you'll know that there'll be 2 on the outside with 1 left over, just because you can kind of group those mental math. Eventually, it takes practice. Okay, with a fraction. Do the top and bottom separate. So I prefer to see the numerator in its own radical and the denominator in its own radical. And we can look at each one separately. Yep. Reduce. Like leave every fraction and reduce. So the square root of 81 is 9. It's a perfect square. There's not anything left over. And we had 2 x's because it's x squared. For every 2, 1 comes to the outside. So there's no more radicals here. These are both perfect squares. 81 square roots to 9, x squared square roots to x. So the denominator cleared radicals. The top here, I'm thinking 25 times 3 y to the third. Square root of 25 is 5. And I have 2 y's here, so I'll bring 1 y out. Oh, that doesn't reduce. 5y square root y all over 9x. Oh, 3. So no, you can't reduce something inside with something outside. Those are 2 different things. If this were like 3 here, I would reduce these. But with this 3 underneath and the 9's not underneath, you can't reduce it. It's stuck like that. So now let's look at those workbook problems. You might have to, do some corrections or finish some, especially with those variables. So take a minute, look at the variables in the workbook page 51 and 52, and write them out and put them in groups of 2 like I just showed you. So it was 1 through 6. Let's keep going. There's number 1, 2, and 3 box. I squared. Okay, let's see how the next one looks. There's 4 and 5. So 4, I showed the x's first. So it looks like there was 1, 2, 3, 4, 5, 6, 7. So I was able to do 3 groups of 2, making it x to the third. 108, 36 and 3. Just leave that out. You don't have to show that work exactly like that. You flip that? Try and flip that. Flip your page. Okay, does anybody have a question about 4 or 5? Okay, here's 6. Doesn't look like I finished it. 1058? I did finish it, yeah. It doesn't divide by anything. It's just like yeah. So that means it doesn't. So that is, oh, I gotta make this a -1 though. Alright, we're gonna keep going on this number 6. So I squared is -1. Turns out that this is 529 times 2. 529 square roots to be 23. I won't ever test you on a number like that. I won't ever test you on like that. So on your test, I'll expect you to know perfect squares up through 12. So 144. 144. Alright, next page. Number 1, 6i. Number 2 is 16I squared. It looks like I did it here. 16I squared, and then make I squared -1, -16. So there's, when the problems get to be, especially with multiplication, there's more than one right way to do it. So this is 2 ways. There could be another way. You know, the idea is that you get down to -16. I'm gonna bet most of you guys did on the right. You made it 256. Let's see a hands up from who made it 256. Okay. Who ended up with the 2 2s? Couple of you. All right, one more. Number 3. -16. So the original problem had so I have 5 on the right. That was the square root of -25. And then on the left it was I squared 15. So I times I is I squared. The I squared is -1. Okay, I have a handout for you to help you. Well, don't put away your stuff because we're gonna do, I think, 2 problems and I give you a handout. To help you kind of organize all of this. There's a lot going on. Like this one section has like 5 or 6 different types of problems in it. So I have a handout for you to help you organize what those are. But before we do that, let's do a couple in your notebook. This one, I wanted to do this one again because yesterday, when we were going over what you had to do with the substitute, I stopped at example 4 and I didn't do example 5, so I wanted to do that. Underneath your vowel as no. No, I picked different color than what you did with this stuff. Being able to simplify radicals and do what you did in yesterday's assignment, you'll see frequently. You'll see that next year, no matter what math class you take next year, you'll do that again. You'll see maybe one on the SAT. You'll see it in college algebra. This, like, a couple more times. This isn't as common as the radicals. But since we talked about it yesterday, it's in your curriculum, we're going to cover it. So find x and y that make the equation true. So right here it says both terms with I are imaginary. So when you looking at the left side equaling the right side, you got to see that 9 is the same as 3x. They're considered the real parts because they don't have I. So 9 matches up with the 3x, and 12i matches up with 4yi. So let me ask you, if this left side is the same as the right side, The 9 is in the same position. Kind of look at them as positions. The 9 is in the same position as 3x. Could you tell me what x is to actually make both those things the same? Gabby? 3. Because 3 times 3 would give you this 9. Okay, that's what you're doing. You're trying to equate the first term here with the first term here. So I'm going to set 9 equal to 3x, like equating the real parts, setting the real parts equal to each other. And then hopefully you can kind of look at it and figure it out. Oh, 3 times 3 is 9. But if not, you're just going to solve a little baby equation, divide both sides by 3, and you get x equals 3. Now, the 12i portion and the 4yi portion are supposed to be balanced. They're supposed to be equal. So what does y have to be if I'm really supposed to have a 12 right there? There's supposed to be a 12 in front of I. Really? So what is y? Y is also 3. You're thinking about what number here would make this equal? What would make the left and the right side the same? So you could set the second part equal. It's not very many places in math that you do this, but so I'll do 12 equals 4y. Now and this was a question you guys had yesterday when I was going over it. Just ignore the I. I'm not ignoring the I, but I'm just trying to figure out what the numbers in front of the I are. So I don't have to include it here, right? Just trying to figure out what the coefficient is. So we'll divide by 4. And that means that 3 is y as well. And I'd like to give you a moment to think about it. So this is supposed to look the same as this. So what does x have to be? -7, right? And what does y have to be? Right, that's the idea. So this is like example 4 that you're looking at with the textbook.
So the answer to -2 is -7.
Correct, yeah. Now look at this. I'm going to say, well, there's supposed to be a -14 here, so what is x? X would be -7. And there's supposed to be a -3 here, so what is y? Oh, y is -3. Yeah, because I'm not questioning like what I is. I'm not solving for I. I'm really just asking. It says find x and y that make the equation true. So you're trying to figure out what would make the left side look like the right side. So we're really just wondering about the numbers in front of I. Yeah. So you could just ignore it, I guess. So that's that concept. Last two things. Adding and subtracting. This was example 5. I didn't go over it yesterday, but it was something I asked you to do out of the textbook. Adding and subtracting complex numbers is just combining like terms. You have to be careful when you're subtracting expressions. You have to distribute minus signs, so we'll start with that. It's like multiplying a -1 to the right there. So I'll drop the parentheses. I'll make it a -7 and a -I, and I'll drop the parentheses and now combine like terms. 8 minus 7 is 1. -5i minus 1 more I, -6i. Yeah, that's it. That's all you can do. That's the answer. So when you're adding, you don't have to distribute anything, like multiplying a +1 doesn't change anything, so you can just drop those parentheses and combine like terms. It's going to be 8. 4 and 4 make 8. -6i plus 6i cancel. So it's just 8. Yeah. Okay, so rather than give you guys my handout, I actually think it would be better just to work your homework with you. So let's just do your homework right now. Guys. Yeah. 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 I might have to take those off and do them tomorrow.
Cool.
And the conjugate. Because
So dumb.
Alright, we're doing 7 through 16. And what I don't like about you guys working on this on your own is that like they all look so different. And 15 and 16 I have to teach you stuff. So I might even change the answer. So 7, multiplication. I'm going to multiply the numbers, the coefficients. 3 times -2 times 5. -6 times 5, -30. I got I times I times I to the third power. Sorry. I don't know why it keeps flying around like that. That is not done. You never want I with a power over anything. You never want I with an exponent in your answer. So we know I squared is special, so we're going to rewrite this as I squared times I to the first. 3 is the same as 2 and 1 more. Take the I squared out and put -1 in. Negative times a negative is a positive. And your answer is going to be I. Who's got a question? I'll try to show you with numbers. Yeah. Yeah, 'cause it's I squared. I have a fourth single I squared times I squared. I to the fourth is actually going to be positive one.
So I to the 6.
Right. Skipping twos. Alright, let's try another exponent problem. I need 11. So you want to rewrite 11 using the power of 2. So start by making it even. Take your exponent even. Alright, so you start by making it even. So 11 is 10 and 1. What you're doing is using properties of exponents, trying to get this down so where you have an I squared, because I squared can replace with negative 1. So 10 is 2 times 5. So I'm going to rewrite 10 as I squared with a 5 on the outside. And that's properties of exponents, which you learn in Algebra 1 and you have no idea. And right now you're learning how to use I, and you have no idea why. But if you continue in math, you'll see why this is a part of your curriculum now. You just gotta trust it. We'll take I squared out and we'll put negative 1 in. This is really just preparing people to become electrical engineers. Yeah. But if there is anybody at Palmetto High School that is going to be an electrical engineer, they are taking this class. So, yeah, there's gonna be some engineers in this classroom for sure. For sure. Raise your hand if you want to be an engineer. Anybody? Not a single person? Well, you guys should rethink it. Somebody is going to be an engineer in here. If not, you guys are making a mistake. I mean, raise your hand if you're planning on going to the medical field. Okay. So raise your hand if you're doing something outside of math and science. Okay.
Unless you count the YouTube algorithm.
What's the science?
Biomedical sciences. Drug.
Yeah, bio is definitely science, but I said that's like the medical field. Yeah, I don't know. I mean, if you want to continue in medicine, like honestly, like doing the MCAT and getting, a degree. I mean, are you guys thinking about being doctors? All right, so like that whole curriculum is gonna make I squared look like the ABCs. So just like keep going with this. This is like no big deal. But also, yeah, consider engineering. Like if you're doing well at this, there's a lot of roles for engineers. It's a good place. But I don't want to discourage you from the medical field. Like go for that. Do that. It's great.
Oh, I know. I wanted to do that.
So we got negative I as our
That's so
answer.
dumb. I wanted
Negative I.
You like watching crime shows? He's like, do you make money off of this?
I'm gonna do 64 times 1. 64 times 1.
She lied.
Yeah, she lied.
Okay, Holly. Yeah.
Two, raise your hand. Be confident and stand out in the crowd.
Yeah.
I don't know that. That's me every time I enter this room. Hey, teacher, where's the homework? You're the person that holds the lotion. Now I'm gonna get ready for tomorrow.
I know, but the people like first thing is going to the medical field. You do have to learn a lot of math. It's like whereas like this is honestly for engineers, not for doctors. And you do it. It's the people who write the curriculum for sciences. They think this is important. So what can you do? Okay. Number so I with those exponents.
I need to take my
Yeah,
phone
just take your
for.
stuff. All right, so when we get to number
Mr.
10,
Fernandez.
we're combining like terms.
I swear that man has it out for me.
No way. Yeah, there's no
Because I
way.
run.
He just wants to go on the soccer team. Combine like terms.
I'll do that.
You should run that.
That's all I can from.
Wait, why did I say
All
that?
right, combine like terms. Combine the parts without I. Combine the parts with I. You guys can skip 15 and 16. I haven't taught it to you today. We'll do it tomorrow. Who's got a question on 10?
Yeah.
we're good.
Wait, what did
Look some kind of guest speaker engineer. Get on board. I've always just not teaching was pretty good. Low pressure.
why were examples to be the student with the subtraction into the equation and then we got addition and this time with the addition and you
The example was when there was a minus sign in between the middle.
does that every time there's a minus?
Yeah.
You just give it.
Yeah, so like in 12 I will.
Okay.
Yep. Other good questions? Alright, so number 11. Combine like terms. So 12 was the first one where we had to distribute a minus sign. Alright, here you're gonna FOIL. Yep, FOILing goes to here. So that's gonna be 14. 33i plus 18 times -1. -4 minus 33i. You guys don't do 15 and 16. I have not done it yet.